Yes, thanks for listening. And Andrew Dunkley here with Professor Fred Watson, of course, and a big hello to all our social media followers. If you haven't started following us on social media yet, I suggest you do. If you've got a Facebook account, you can join the Space Nuts Facebook page. But there's also a Space Nuts podcast group on Facebook, which is it's geared to basically give you an interface between fellow listeners. So you can all get together and chat and swap ideas and ask questions of each other. It can be anything from, showing off your telescope right through to talking about something extraordinary that's been discovered in the universe and putting theories and discussions behind it. So it's a great little group and a lot of fun. So look for it on Facebook. Just do a search for Space Nuts or Space Nuts Podcast Group. Join both. Why the heck not? I mean, cost you nothing. Cost you nothing. Okay, Fred, let's move on. And we've talked about the asteroid that killed off the dinosaurs, which plummeted into what is now the Gulf of Mexico, or part thereof, around 66 million years ago, 66 million years ago. One of the great mysteries of this is we don't really know where it came from, and they've been trying to figure that one out. Have they come up with a theory? Or indeed an answer?
Could be an answer. That's right. It's this is really interesting work in terms of our understanding of the asteroid belt in particular, but the frequency with which the Earth might be zapped by impactors. So what's happened is that do you remember Myrtle, Andrew? Myrtle was the drilling rig in the Gulf of Mexico that drilled down to get samples of the material that this asteroid was made of. And I assume from what I've read about this work that we're reporting today, that is one of the sources where these rock samples have come from, the Myrtle drill cores. Because what turns out to be the case is that the drill core samples and other rock samples as well, which are from the area, excuse me, indicate that the asteroid that wiped out the dinosaurs, the Cretaceous Tertiary impact, as it used to be called, it's called something else now, 66 million years ago, that asteroid was actually a particularly a fairly rare type of asteroid, which is called a carbonaceous chondrite. And as the name implies, these are stony asteroids, but they're rich in carbon. They're quite dark in color. And what the scientists have done, I can't remember whether I mentioned it already, but it's come from SWIRI, the Southwest Research Institute, which is I think it's Colorado, if I remember rightly. That's where the team of scientists that have done this work are based. They do marvelous things at SWIRI. The whole of the outer solar system is their regime in terms of understanding what's going on. But this work, it's looked at whereabouts these things come from in the asteroid belt. And it turns out that when you examine, and I'm talking now about the main asteroid belt between the orbits of Mars and Jupiter, not the trans-Neptunian objects or the Jovian Trojans or anything like that. This is the main asteroid belt. The carbonaceous chondrites tend to inhabit the outer region of that asteroid belt, so they're nearer to Jupiter. And it was always thought, or it has been thought, that those objects wouldn't find it easy to whiz in towards the inner solar system. I mean, the asteroid belt is pretty stable, which is why it's there. It's all this collection of debris that maybe would have formed a planet had Jupiter not been so near. It's thought Jupiter might have, disturbed the formation of a planet between Mars and Jupiter. And what we're left with is the debris, the planet that never was, the asteroid belt. But the asteroid belt itself is divisible into many different sectors. And the outer region is where these carbonaceous chondrites tend to hang out. And so what scientists have wondered about is there a mechanism that gets them into the inner solar system where they might collide with Earth? And what they've done is they've run many simulations of the way the gravitational field of Jupiter and Saturn and other planets kind of tickles these these asteroids at the far boundary of the asteroid belt and pushes them into orbits that will bring them towards the inner solar system. And sure enough, that works. They can produce a scenario where this happens, and that's allowed these scientists to do statistical analysis on that kind of phenomenon, that these asteroids are tipped out of their stable orbits on the edge of the asteroid belt and pushed into orbits that will intersect with the Earth's orbit. So they, in fact, their statistics suggest that a 10-kilometer asteroid of the kind that wiped out the dinosaurs would hit the Earth on average once every 250 million years. And that's sort of ties in with, the Chicxulub event, the crater that is the result of that dinosaur wiping out impact 66 million years ago. And more than that, they found that when they analysed these asteroids, more than half of them would have been carbonaceous chondrites, exactly what we find with the Chicxulub impactor. So really, what it does is it sort of lets you look as well. I mean, let scientists look at the other big impacts that have affected the Earth's history. The dinosaur killer is the one we all talk about because it probably opened the way for the evolution of mammals, eventually ourselves. Had it not happened, the dinosaurs might have hung around a lot longer. But there were other impacts as well in the Earth's history, and so they're looking at these too to see, how many of those were carbonaceous chondrites and whether it matches the statistics that they're forecasting.
Yeah, it does appear that these impacts by carbonaceous chondrites are more common than they originally thought. Is that a fair statement?
I think that's right. Yes, and it's actually interesting because it ties in with some other research that was released this week, which I haven't got in front of me, but that's about the way planets have changed the orbits of asteroids. And it's a surprise, actually, because there are some even more carbon-containing asteroids which are extremely red in colour, and most of them are the trans-Neptunian objects. They're the Kuiper Belt objects beyond the orbit of Neptune. But it turns out that there are a few of those in the main asteroid belt, and that's suggesting that gravitational processes have allowed these very, very red objects, really primitive objects, which are basically leftovers from the formation of the solar system. It's allowed those to come out from the depths of space, which is where they would have been formed, and inhabit the main asteroid belt between Mars and Jupiter. It's, so that they can see gravitational mechanisms by which that might happen, which kind of ties in with what we've been talking about. That's completely independent research.
And it's not surprising that they used computer modelling to figure all this out, because how else can you do it? But they used NASA's supercomputer Pleiades, which I think was portrayed in the movie The Martian, to solve an orbit and retrieval system to rescue the stricken astronaut. But they looked at like 130,000 model asteroids to work out how these things get shifted out of their position. And I think the answer was some sort of thermal effect. I think was
that's right.
Thermal forces.
Exactly. So it's the way they're heated, and perhaps heating on one side rather than the other preferentially changes the orbit.
Yeah, fascinating. All right. So now we know where it came from, and we hope there are no more. But that stands to reason that these things continue to happen. We just so every 250 million years, we've still got around 180 million years to wait. We should be fine.
But remember, it's statistics though, and it could happen tomorrow. Except the good thing is that we've got something the dinosaurs didn't have, which is telescopes all over the world, which are looking for these things. So.
And nuclear bombs and Bruce Willis.
And Bruce Willis, of course, yes.
Yes.
All of the above.
Going to save us all. It's good, though, that they've been able to track it down.
Yeah.
This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.